Hi, I am T. Kavitha, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science. Today's topic is Introduction to Linear Programming Problem. Linear programming is a mathematical technique used for optimizing a linear objective function subject to a set of linear constraints. It is widely used in various fields such as economics, business, engineering, and logistics to maximize profit or minimize cost under given conditions. Linear programming is a powerful optimization tool used in various industries to improve efficiency, minimize cost, and maximize profits. It helps business determine the optimal mix of products or services to maximize profits. It reduces production, labor, and transportation cost while maintaining efficiency. Now we go. This is the structure of linear programming problem. The introduction. Linear programming has nothing to do with the computer programming. The use of word programming here means choosing a course of action. Linear programming involves choosing a course of action when the mathematical model of the problem contains only linear functions. The maximization or minimization of some quantity is the objective in all linear programming problems. The objective is maximization or minimization, maximizing the profit and minimizing the loss. This is the objective for this problems. All LP problems have constraints that limit the degree to which the objective can be pursued. A feasible solution satisfies all the problem's constraints. An optimal solution is a feasible solution that results in the largest possible objective function value when maximizing or smallest when minimizing. The optimal solution is a feasible solution that results in the largest possible objective function value when maximizing or smallest when minimizing. A graphical solution method can be used to solve a linear program with two variables. Next, how to formulate the problem. If both of the objective function and the constraints are linear, the problem is referred to as a linear programming problem. Linear functions are functions in which each variable appears in a separate term raised to the first power and is multiplied by a constant which could be 0. Linear constraints are linear functions that are restricted to be less than or equal to or greater than or equal to a constant. Next, problem formulation or modeling is the process of translating a verbal statement of a problem into a mathematical statement. Formulating models is an art that can only be mastered with practice and experience. Every LP problems, that means linear programming problems, has some unique features, but most problems also have common features. General guidelines for LP model formulation are illustrated in the slides that follow. Guidelines for model formulation. The steps are: understand the problem thoroughly, describe the objective, describe each constraint, define the decision variables, write the objective in terms of the decision variables, write the constraints in terms of decision variables. This is the example for simple maximization problem. Here the objective function is maximize z is equal to 5x1 plus 7x2. The regular subject to constraints is 2x1, x1 less than or equal to 6, 2x1 plus 3x2 less than or equal to 19, x1 plus x2 less than or equal to 8. and the non-negativity constraints x1 greater than or equal to 0 and x2 greater than or equal to 0. The key components of a linear programming problem is first, decision variables. These represents the choices available to the decision maker. Example, the number of units of a product to produce. The next keyword is objective function. The objective function is a mathematical function that needs to be maximized or minimized. Example, maximize z is equal to here given 5x1 plus 7x2. Then constraints. Constraints means a set of linear inequalities or equations that the limit of the feasible solutions. Then last one, the non-negativity restriction is the decision variables must be non-negative. That means x1, x2 greater than or equal to 0. The mathematical formulation of LPP, the structure is objective function, then subject to constraint, then non-negativity condition. Applications of linear programming is manufacturing, transportation, finance and agriculture. Optimizing production schedules. That's it. Thank you.